In this video, we're going to learn how to use the concentration formula. And what we have here is a problem from our textbook. It's page 148 of Brown, the practice exercise A. And what we have is a solution that has a concentration of 0.5 molar sodium sulfate. And there's a 15 milliliter sample of it. How do we find the number of grams of sodium sulfate contained within that sample? Well, we begin with this formula where N stands for moles, M stands for the mass of the substance, and the M is the molar mass. And we rearrange it so that we're solving for the mass. Then we rearrange the equation once again. Sorry, there's two problems in one here. In the first instance, they ask us to find the number of moles. Okay, so we use this equation, we rearrange it to solve for the number of moles, and the concentration is 0.5 molar. The sample size is 0.015 liters, so it tells us that we have 7.5 times 10 to the minus 3 moles of sodium sulfate. Then, having found out how many moles are in the sample, we find out the molar mass of sodium sulfate because it wasn't given, and we can multiply the number of moles of sodium sulfate by the molar mass to find out how many grams of sodium sulfate is necessary. Then when we report it, because we're constrained by the fact that there were only two numbers, there were only two significant figures in one of the numbers that we use for the calculation, we're constrained to use only two numbers to report the answer. So the answer is 1.1 grams once we round it off. In the next example, we're asked, what is the concentration of the solution made by dissolving 45 moles of glucose into 220 liters of water, presumably? How many grams of glucose is needed? So it's a two-step problem. The first step in the problem is to find out the concentration of the glucose. So we use the equation, the molarity is equal to the number of moles divided by the volume. And there are 45 moles, we're told. The volume of the final solution is 220 liters, so it's simply a question of dividing it. We get 0.2045 with the 45 recurring. And when we report it to only two significant figures because there are only two significant figures here. So the answer would be 0.2 moles, or 0.2 molar. It's the concentration, moles per liter. Then we're asked how many grams of glucose are in 45 moles. So we use this equation. The mass divided by the molar mass tells you how many moles you have. So I've rearranged the equation to solve for the mass by transposing the molar mass. We know we have 45 moles. We calculate the molar mass of glucose, which is around 180, times the 45 gives you 8,107 grams of glucose. We round it off to two significant figures, so it's 8.1 times 10 to the 3 grams of glucose is needed to prepare this solution. The next problem also comes from the textbook. It's part B of the same problem from page 148. In this one, we're asked how many mLs of solution is necessary to make if you have a 0.5 molar concentration of solution, how many mLs do you need to take to get 0.038 moles of the substance involved? And it's not even necessary to know what the substance is because there's no mention of its molar mass, and it doesn't even enter into it when we solve the problem. They're asking us for how much volume. So what I did is I transposed the volume part of the equation, getting molarity times volume is equal to number of moles, and then I transposed molarity to isolate V, which is what we're looking for. I then entered the two values that are given in the problem, 0.038 moles divided by 0.5 moles per liter, and it tells us that we need 7.6 times 10 to the minus 2 liters. I then multiplied by 1,000 to convert liters into milliliters. Notice how that conversion factor allows us to cancel liters. Our final answer is 76 milliliters. This is another problem similar to the one we did here, except we're asking for different concentrations. How many milliliters of a 0.35 molar solution are needed to have 0.16 moles of glucose? Again, we start with the equation. We transpose the variable V what are we doing? We're trying to isolate for V. So how do we isolate V? Is to bring it up to the other side of the equation, and then we bring M away, so that we find out that the volume is equal to the number of moles divided by the molarity. We enter the two values that we do have, 0.16 moles of glucose, and its concentration is 0.35. It means that it requires 0.457 liters of solution to get that many moles. And then we can, again, multiply by 1,000 to get the number of mLs, which is 457. Lastly, we are asked how many moles of ammonium phosphate is removed from a solution if a 112 ml sample is taken from a 0.45 molar solution. In this case, we're only asked for how many moles are removed. So we have to isolate the variable n. We transpose the v up, mv is equal to n, and then we enter the two variables, the two numbers, 0.45 moles per liter, 112 thousandths of a liter, because remember there's 1,000 mLs per liter. When we multiply the values, liters cancel, our answer is in moles, and the answer is 0.0504 moles of ammonium phosphate is removed.